Now, looking at example 6, again, we've used substitution exclusively, and I just got done telling you in example 5 that coefficients of 1 are your best friend, right? We look at this problem, and how many coefficients of 1 do we have? We don't have any, right? So all of a sudden, now we're looking at this problem that, like, well, Mr. Klein just said we want coefficients of 1 to do substitution, and then he throws one at us like this that has no coefficients of 1. So here's a scenario where I'd want to use a different technique, and this technique is called elimination. Okay, first thing about elimination, very, very important, is you want a specific structure to do elimination, always. The structure is exactly this. Something x plus or minus something y equals some number. You want both equations to be in that exact structure. The x's and then the y's and the equal signs, then the numbers. That's what you want every single time. Everything lined up just like that. Okay? Once you make that structure like it is, which is good in this case, all right, next you're going to look at how do I make one of these variables disappear. And you're looking to make opposites. Opposites are the same number with different signs. And what you're looking at here is the yellow highlights, the signs are the same. The green highlights, the signs are different. I don't care about the blue highlights. I'm looking to get rid of x or y. I want to eliminate x or y. So I'm looking to make opposites. For me personally, if I already have opposite signs, I'm going to go with that one. So if this is me doing this problem, and I'm going to use elimination, I make that decision because, again, I see no coefficients of 1. So substitution would not be a pleasant process in this one. I'm asking myself, using multiplication only, how can I make the two green highlighted numbers become the exact same number but opposite signed? How would I do it? Multiply the bottom by 2. If I do 2 times negative 2y, I get negative 4y, which is the exact opposite of positive 4y. Sometimes I got to multiply both equations times something, sometimes only one equation. But again, my goal is to get these numbers to be opposite of one another. So I'm going to take the bottom equation, I want to multiply by 2 because I want this to be negative 4y. I don't care what happens to everything else. I have to change everything else, but I don't care what happens to them. So what's in blue is what I want to happen. What's in red is what the consequence of my action is. In algebra is a lot of that. You change things up, there's a consequence to your action. So the top equation is being left alone. It's going to stay as is. So the top equation, I'm going to rewrite it. So it's going to be 7x plus 4y equals positive 25. The bottom equation, I'm going to carry out the multiplication. 2 times all 3 pieces. 2 times 3x makes positive 6x. 2 times negative 2y makes negative 4y. 2 times positive 7 makes positive 14. Okay, make sure that you're thinking through the signs as you're doing this. It's not just numbers, but it's a sign and a number. So a positive 2 and a positive 3 makes a positive 6. Positive 2, negative 2 makes negative 4, and so on. So all the right signs have to be here. And if you did that step correctly, you should expect to see the object you wanted to get rid of, either x or y. In this case, we want to get rid of y. You should see opposite coefficients. Once you see opposite coefficients, now it's just a matter of add the two equations together. Add straight down the x's, straight down the y's, straight down the numbers. So 7x and 6x, same sign I'm going to add. I get 13x, both positive, so it's positive. Positive and negative 4y cancel. That's the elimination idea. We're eliminating y from the problem, getting it out of the picture. And then 25 and 14, both the same sign. I'm going to add. 25 is bigger, so it's positive. And just like that, the problem that had both x and y variables in it now only has x in it. So the last step to figure out what x equals, I divide both sides by 13. You always want x equals, so the numbers in front of x must be divided. So 13 divides both numbers. 39 divided by 13 happens to equal the pretty number positive 3. Once I know what either x or y equals, I go back, either substitute that answer in to find y, or I go back and eliminate x. I can eliminating y found x, so eliminating x is going to find y. My task is to find both. So I'm going to go with option A. Anytime I know what x equals some number, I can go back here, or I can go back here, change x to that number to solve. I'm going to go to the top equation. So top equation says 7 times x equals 3, plus 4 times y equals 25. Again, that's exactly what the equation says. I simply changed x into the number 3 because that's what x equals. 7 times 3 is 21. Just like that, we get ourselves a basic solve for y equation. I'm going to move the 21 over there, so y is by itself. Move 21 across, becomes negative, so 4y equals 4. These signs are different, that's why I subtract. 25 is bigger, that's why it's positive. 4y equals 4, we divide both sides by 4, and we get y is equal to 1. X equals 3, y equals 1. Our ordered pair is x first, y second. 3, 1 is the correct solution to this equation. Just real quick, again, that's everything you have to do. Just to show you this, because again, this is an option also. Sometimes this answer is not a pleasant answer. Maybe this answer comes out to 17/437. And all of a sudden you have to put in 17/437 here, and that's going to be pretty unpleasant, right? So you did everything right, you got this unpleasant answer, which is very possible. So the other option, rather than going back and substituting to figure out what x equals, or to figure out what y equals, again, if I eliminate x, what number can I make those 7 and 3 that are opposites? 21, right? One positive 21, one negative 21. So if this were me, and again, I got some unpleasant answer here, x equals some like ridiculous fraction, and I don't want to substitute some ridiculous fraction to find out what y equals, I would just take this times, let's say times positive 3, take this times negative 7. It doesn't matter which one's positive, which one's negative, just make sure one of each, right? So the top times positive 3 would make 7x times positive 3 is positive 21x. 3 times positive 4y is positive 12y. 3 times positive 25 is positive 75. Negative 7 times positive 3x is negative 21x. Negative 7 times negative 2y is positive 14y. Notice it's positive because two negatives make a positive. And negative 7 times positive 7 makes negative 49. Get what you get, all right? The signs are what they are. Positive times positives all make positive on the bottom. Negative times positive makes negative. Negative times negative makes positive. Negative times positive makes negative. Just like over there, my goal was to get opposites. Notice now my x column represents opposites. So now I'm going to do just like I did to find out what x equaled. I'm going to add the equations together. These being opposites cancel. 12y and 14y, same sign, add, you get 26y, positive because 14 is bigger. These signs are different, so I subtract. 75 is bigger, so it's positive. Divide both sides by 26. And just like that, y equals 1 also. Again, y equals 1, that is the answer y is. So whether you go to use elimination to figure out what it is, once you know what x is, you can go back and substitute to find out what y is. Again, as long as x is a friendly answer, I'm going to substitute. If x is unfriendly, I'm going to go back and eliminate the other variable to find y. So take your pick, practice the skill, get good at it. Both these techniques work 100% of the time. Elimination, in my opinion, works easier all the time. But if I have one coefficient, a lot of times I use substitution just to practice the skill. Okay. So that's how you do it, and continue on your homework. Again, if you hit weirdness in your homework, if all the variables disappear in your work, stop. Don't go any further. We're going to learn how to deal with those in the next day or two.